Lessons, we'll do 5.5 and 5.6. We're going to do law of sines today. Law of sines will be 5.5a and 5.5b, and then law of cosines will be 5.6a and 5.6b. Now, you've already seen the law of sines and law of cosines. You did in geometry. I didn't know that until I talked to Miss Cowie, and she's like, oh, yeah, we're doing law of sines. I'm like, what? Okay. Now, a triangle has how many parts? How many parts does a triangle have? 6. 6 parts. What are they? Perfect. 3 sides and 3 angles. 3 sides, 3 angles. So when we're asked to, quote unquote, solve a triangle, that means they're going to give us some of the parts and we have to find all the other parts, the measures of them. Okay? So to solve an oblique triangle, you need to know at least one side and any other 2 parts. Okay, you have to have a side of a triangle. If you have angle, 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 you can make any triangle. You can make a small, teeny triangle that has the same angles as a huge triangle has the same degrees angles. They're similar, but they're not congruent. Okay? Now, you're like, oh no, congruence, angle, side, angle, 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 side. We're not doing proofs of geometry, okay? But they do call them angle, side, angle, and stuff like that. All right, so here we go. The first type that we're going to have are the ones that we're going to do today. And that would be that you are given a side and 2 angles. You're given a side and 2 angles. So there's 2 types of these that we're going to do. We're going to do angle, angle, side. So 2 angles and then a side on the other side of it, not between the angles. That's different, okay? And then we're also going to do today angle, side, angle, which would be 2 angles and the side in between them. And then we have to find all the other parts. Now, it's really cool when we're given 2 angles, you can find that 3rd angle very quickly, right? Not using any trigonometry at all. Okay. All right, number 2, the one that we're going to do on Monday is going to be the trickiest one of all. That is when you are given 2 sides and the angle opposite of one of them. So an opposite angle, and we call this one side, side, angle, not to be written as angle, side, side ever, okay? Side, side, angle. Some people call that the donkey theorem, because you know ASS, kind of funny. Yeah, this one has some options. Like if you are given the side and another side and the angle opposite one of those sides, then what can happen is no triangle can be formed, or 1 or 2 possibly. So there's some options on that one. The ones we're going to do today are easy. That's Monday, so we're going to make Monday even worse. Okay, those 2 right there are going to be lesson 5.5. Okay, we're going to use law of sines to solve those, and I'm going to tell you what the law of sines is in just a minute. All right, the next 2, we're going to also have be given 3 sides of a triangle, so side, side, side. And then we're also going to be given 2 sides and the included angle. The angle in between them, and that's SAS, side, angle, side. Okay? So we never have angle, angle, angle. That's not going to work. So these both come from 5.6, which we're going to learn as the law of cosines. Back to it. All right, now the law of sines. Here we go. Let's go ahead and let me show you what the law of sines is. So go ahead and draw a triangle. Draw an oblique triangle. My triangles always either look like isosceles or they look right triangles. This is not a right triangle. It's just your basic triangle, okay? And let's say that over here we have angle A, and angles are always capital letters, and across from angle A is side A, okay? And then over here, this is angle B. This projector's getting warm, huh? And across from angle B is little side B. And then this up top we call angle C, little side C. Okay? And the law of sines is really simple. It's clean, it's nice, it's pretty. What it says is this. If you have side A and you divide it by the sine of angle A, it's going to equal side B over the sine of angle B, which is also equal to side C over the sine of angle C. Beautiful, right? All their ratios are equal to one another. Okay, do you remember this at all from geometry or no? Geometry's a blur? It's like one lesson, one day, so it's kind of hard to remember that. Also, if you flip all of them, they work that way too. So the sine of angle A over side A equals sine of B over side B equals sine of C over C. And I'm sure you're sitting there going, why? How does that work? Well, guess what? We're going to prove it. I said no proofs, but you know, you can't just be given a formula and be like, be okay with that, are you? No. What if I'm lying to you? That's on me. That's so cute. All right, the proof is simple. It is. It's actually one of the more simple proofs. So this is what we're going to do. Go to your triangle and drop a perpendicular down from angle C right here. And what that does is that splits up this into two triangles. And they both have side H. Okay, here comes the proof. Are you ready? All right, so go to that triangle now, and using SOHCAHTOA and what you learned way back in chapter 4, what is the sine of angle A? Using that little right triangle right there. Perfect, H over B. Okay, you see it? Opposite, so here's angle A, opposite over hypotenuse. Now let's do the same thing, but for angle B. And let's use the other triangle. So let's go to angle B, and the sine of B is what? H over A. It's the same H though, isn't it? So let's go to this sine A equals H over B, and let's solve for H by multiplying both sides by B. So H equals B sine of A. But H also equals A sine of B. So I went ahead and solved for H here, solved for H there. And since those H's are equal to one another, let's just use substitution and set these equal to each other. So that tells us that the B times the sine of A equals A times the sine of B. Divide both sides by A, divide both sides by B. Sine of A over little a equals sine of B over little b. Proof's done. Nice, isn't that nice? Nice and clean. Very easy proof. You all followed along. There you go. It said I had to do that. The objective for today, students will be able to understand the proof of the law of sines and then use the computational applications to solve some triangles. So I had to. The book told me to. Now let's do our two examples. Are you ready? Let's do them. Two examples, that's it? Yeah, that's it. Nice, easy Friday. After that test, you know, we got to kind of chill for a minute. Okay, so here we go. We're going to do examples of angle, angle, side, and angle, side, angle. So number one, we're going to solve this triangle. This triangle is an angle, angle, side triangle. We have two angles and a side not in the middle of them, but on the side of them. And so my suggestion to you, you know, you don't have to take this or not, but I would go right to solving for angle A because you don't have to use any trig. All you need is a little bit of geometry knowledge to solve for that angle. So let's find out what A is. A is right here, and angle A is going to be, yes, 180 minus 105 minus 41. Would you get 34? 34 degrees. It's definitely not 34 degrees in here. All right, so once you get one of them, put a little box or circle around it so you can see when you check your answers, it'll be nice and easy. So now we need to find two more parts. Okay, so they're going to give you 3 parts. You have to find the other 3. So let's go ahead and let's find side C next. Side C. So we're going to set up a proportion or a ratio. And I like to start with whatever I'm trying to find. Okay, I'm trying to find side C. So that's going to go up top. It doesn't have to. It's just I think this is an easy way to do it. So I'm going to do C over the sine of C, which is 41 degrees, equals, and I'm going to use the ratio that they gave me, which is right here. I have side B and angle B. So it's equal to 12.6 over the sine of 105. Okay? And so let's solve for C by multiplying both sides by sine of 41. And that's where you're going to need your calculator a lot for these. And I have you rounding to 1 decimal place. So put it to the nearest tenth. So this is what I would do. I would go 12.6. Make sure you're in degree mode. Can't see that, can you? Nope, still can't. Up there? Sort of. All right, 12.6 times the sine of 41, close your parentheses, divided by the sine of 105. 8.6? Yes? All right, try it on your calculator. Don't just, okay, yeah, I know how to do that. Sometimes you plug stuff in wrong, and we got to figure that out now before you get to a test or quiz. All right, so C is 8.6, and now I have one more to solve. What's that? Oh, good. Yes, yes, yes. Approximately 8.6. Cassidy's right. Okay, and then finally we'll solve for side A now. What was that? That's okay. A over the sine of 34 equals, and I'm just going to set this equal to my same ratio. All the ratios are equal to each other. So I'm going to keep 12.6 over the sine of 105. And you know what? Here we go. These calculators? Oh, I deleted it. Dang it. Did you do it? You can hit second enter and then go back and change 41 to 34. Did you do that? I didn't. Dang it. All right, 12.6. I got to type it all in again. Times the sine of 34. Make sure you close that parenthesis. Divide by the sine of 105. So A is approximately what? 7.3. Good job. There you go. Do you like this better than proving identities? I don't. You do? I don't. I love that last chapter. I'm sad that it's over and I have to wait a whole year to do it again. Wow. Come by next year and do them with me. No? You'll have your own problems. I assure you yours will be greater if you're in AP Stats or AP Calc or Stats. Okay. All right, number 2. Solve the triangle. It'll be okay, though. All right, solve the triangle. Now, personally, I like to draw a triangle, especially in my spare time. Just kidding. There you go. It's fun because when I go outside and play with the kids and we draw chalk on the sidewalk, I always end up drawing like cones and prisms and spheres and geometrical shapes. And like, draw a tree. Nope, don't know how. Okay, so this is A, B, and C. It doesn't matter what you label them. And my triangles are never drawn to scale. It doesn't matter either. So this is 96 degrees. And B is 48 degrees. And then across from A is side A, which is 8. Now, in this problem, I was not given a ratio. I wasn't given angle A and side A or angle B and side B. But I can go ahead and start by finding angle A first. That's my first step. Especially when they give you 2 angles, find that third angle right away. So angle A is equal to, what'd you get? 36? 36, don't forget degrees, because it's definitely not 36 radians. That would be a big angle. All right, 36 degrees. So here we go. Let's set it up. Which one should we solve for first? I'm going to solve for side C, if you don't mind. So I'm going to go side C over the sine of 96 is equal to side A, which is 8, over the sine of 36. By the way, if you do flip those, that's okay. It's just I always like to start with what I need to solve. That way I don't have to cross multiply. I have that up top already, and I can just multiply by sine 96. So go to your calculator and go 8. You don't even need the times. You can just go 8 sine 96, and then divide by, close parentheses, divide by sine of 36. And what'd you get for C? 13.5. Did you get that? Yeah? Okay, good. All right, and then we'll go ahead and find out what side B is now. So I would do B is what I'm looking for over the sine of 48 equals 8 over the sine of 36. Use that same ratio, and then you can hit second enter and change that 96 that we used here into a 48. Just, you don't have to do it that way. And you get what, 10.1? 10.1. Perfect. And there you go. You solved it. And that is it for